In this Easy Ed video lecture, we will be learning another types of motions related to kinematics of particle like relative motion, and the velocity of the blue bus is negative according to the coordinate system. The general equation for relative velocity is given as velocity of red bus with respect to blue bus equals velocity of red bus minus blue bus. Since the velocity of the blue bus is negative, so the relative velocity of red bus with respect to blue bus is given by the following equation. And the relative velocity of the blue bus with respect to the red bus is given by the following equation. Again, the two buses, the red bus and the blue bus, are traveling on a straight highway. Both the buses are moving in the same direction, that is parallel to each other. An observer is watching the buses running on the highway. Here, the velocity of the red bus is positive and the velocity of the blue bus is also positive. So the relative velocity of the red bus with respect to the blue bus is given by the following equation. From the given example of the relative motion, we can say that the relative motion is the calculation of the motion of an object with regard to some other moving object. Let us understand relative motion with the help of an example. Consider two trains leave a station in different directions at the same instant. Train A travels at 300 km per hour at 15 degrees west of north, while train B travels at 400 km per hour at 50 degrees east of north. Find the relative velocity of train A with respect to train B and the separation of train A after 3 minutes. Given that the velocity of VA is 300 km per hour at 15 degrees west of north, now VA bar is given as Vxi plus Vyj. Vx is given by Va sine 15 and Vy is given by Va cos 15. The sign component will be negative as per the coordinate system. On evaluating, we get Va as shown. Similarly, evaluating for Vb, we get the equation as shown. Therefore, the relative velocity of a train A with respect to train B is given by the relation shown. On evaluating, we get the relative velocity of train A with respect to B. Now draw the position vector of train A and train B. So the relative position of A with respect to B is shown by vector. Now velocity is distance upon time. On substituting the respective values, we get the relative position of train A with respect to train B after 3 minutes.
In this question, we need to determine the relative velocity and acceleration of car B with respect to car A. We will assume up is positive and to the right is positive. Let's write the velocity of car A in Cartesian vector form. Since it's going in a straight line to the right, it's going to be 30i. Now we can write the acceleration in Cartesian form as well. That's going to be 2i. For car B, we also need to write the velocity and acceleration. Let's focus on velocity first. We have two components, which are 15 cos 60 degrees and 15 sin 60 degrees. Let's simplify these. For acceleration, it's a bit more complicated. The car is traveling along a curve, which means we will have tangential acceleration and normal acceleration. So let's find those first. The tangential acceleration is 0.8 meters per second squared, which is given to us in the question. The normal acceleration can be found using this equation. The radius of curvature is 250 meters and the velocity is 15 meters per second. So let's plug those in and solve. Now we can express each of the accelerations in Cartesian form. So for each acceleration, we will write the I component and the j component. For the tangential acceleration, since it's slowing down, the arrow is pointing backwards, which means both components are negative. For the normal acceleration, it's pointing to the center of the curve, so we have one component that is positive and another that is negative. Let's simplify these. The total acceleration of car B is the addition of all of these components. Let's add the components together. Now that we have the velocity and acceleration, we can use our relative equations. For velocity, we have this. Plug in what we know and solve. Now we can find the magnitude of velocity. The angle can be found using tan inverse. For acceleration, we will do the same, using the relative acceleration equation. Plug in what we know and solve. Now let's find the magnitude. The angle can be found using tan inverse. Those are our answers. Thanks. In this question, we need to find the relative velocity and acceleration of cars A and B. We will pick up and to the right to be positive. So for car A, we can break down the velocity into x and y components. For the x component, we have 10 cos 45 degrees, and for the y component, we have negative 10 sine 45 degrees. Let's simplify them. For car B, we only have the x component, so it's just 18.5i. We can now use the relative velocity equation. Remember that the question is asking for the relative velocity of car A with respect to car B. We can now find the magnitude. The angle can be found by taking the tan inverse. Now we can focus on acceleration. Since car A is going along a curve, we will have a normal acceleration along with a tangential acceleration. The tangential acceleration is given to us in the question, which is 5 meters per second squared. The normal acceleration can be found by using this equation. Let's plug in everything we know from the question and the diagram. The acceleration can be written in components using both the normal and tangential acceleration. So for the tangential acceleration, we have the I component and the j component. For the normal acceleration, we have these components. Let's simplify them. The acceleration can be written as the addition of these components. For car B, we only have tangential acceleration, and so acceleration can be written as just one component. Now we can use the relative acceleration equation. As before, it's relative acceleration of car A with respect to car B. Let's find the magnitude now. The angle can be found using tan inverse. Those are our answers. Thanks for watching, and I hope that in this question, we need to determine the velocity of the rain as seen by the driver of the car. We will assume up and to the right to be positive. So we need to write the velocity of the car using components. Since it's traveling in the horizontal direction, it will only have one component, which is the I component. We need to convert 100 kilometers per hour to meters per second, which gives us 27.78 meters per second. So the I component is negative 27.78i. Negative because the car is traveling to the left and we chose right to be positive. The rain is falling at an angle, so we need to break it into two components. We have 6 sine 30 degrees and negative 6 cos 30 degrees. Let's simplify the values. Since the question asks us to determine the velocity of the rain as seen by the driver, we need to find the relative velocity of the rain with respect to the car. So we can use this equation. Let's plug in the values we know and solve. Now let's find the magnitude. The angle can be found using tan inverse. Those are our answers. Thanks. In this problem, we need to figure out the relative velocity and how long it will take for the boats to be 600 meters apart from each other. We will assume up is positive and to the right is positive. So let's start off by breaking the velocity of boat A into two components. We have negative 10 sine 30 degrees and 10 cos 30 degrees. Let's simplify them. Now we will do the same for boat B. We have 15 cos 45 degrees and 15 sine 45 degrees. Let's simplify these. Now it's time to find the relative velocity. Remember, we're trying to find the velocity of boat A with respect to boat B. Let's plug in what we know and solve. We can now find the magnitude of velocity. The angle can be found using tan inverse. To find how long it takes for the boats to be 600 meters apart from each other, all we need to do is divide distance by velocity. We get 38.2 seconds. Those are our answers. In this problem, we need to determine the velocity of plane B with respect to plane A. We will assume up is positive and to the right is positive. Let's write the velocity of plane A in Cartesian vector form. So we have negative 500j. Negative because the plane is heading down and we chose up to be positive. For plane B, we see that its velocity can be written in terms of I and j. So we have 700 sine 60 degrees and 700 cos 60 degrees. Let's simplify it. Now we can use our relative velocity equation, keeping in mind that we are trying to find the velocity of plane B with respect to plane A. Let's plug in what we know. We can now find the magnitude. The angle can be found using tan inverse. Those are our answers.